morning, my dear students. My name is Twayna. I am currently available at the Hamlet Tuition Center, Brahmatol, Kathmandu. If you want to contact me, my contact number is 9849135739, and I'm also available at the Kumudini Kunja Secondary School, Kalimati, Kathmandu. My dear students of grade 9, this is your science class, and in your science class we have been discussing about the lesson electricity. And in our previous class we discussed about domestic wiring system or household wiring system. Yes, and we left at the fuse. Last time we left at the fuse. Okay, today we will catch up from there. We will discuss about fuse. Okay, what is fuse? Well, we have already introduced that while discussing about household wiring system. Yes, fuse is a simple piece of wire, which would melt when excess amount of current flows through it. Okay, fuse is an external piece of wire, a simple piece of wire which would melt down when certain amount of current flows through it. You can see in this picture, fuse is inside. It is kept inside a cartridge. Yes, outside the wire is so thick, but inside you can see a thin piece of wire has been kept, isn't it? So let us suppose that the wire has capacity of 15 ampere. The wire can withstand up to 15 ampere of current. If more than 15 ampere of current flows through the wire, it might cause overheating of the wire, and that might melt the insulation of the wire and even cause house firing. Yes, so flowing of higher current than its capacity is detrimental, devastating. Okay, that is why, let us suppose, to protect the circuit, we have kept this small piece of wire in between the two pieces of wire. Yes, this red wire, in between these two pieces of wire, the circuit is completed by using this small thin piece of wire. And this piece of wire, it has lower capacity. Let's say its capacity is 7 ampere. Let's say its capacity is 7 ampere, whereas the capacity of the wire here is 15 ampere, isn't it? So the effect here is, if somehow 8 ampere of current happens to flow through this circuit, then because of that current, this wire would get overheated. Just like this wire would be overheated at 15 ampere current, this wire would be overheated at 7 ampere of current. And this wire is made up of special metal. It is made up of an alloy of tin, alloy of tin plus lead. Okay, and this alloy means, you all know that alloy means homogeneous mixture of metal. Yes, homogeneous mixture of metal. This alloy, tin and lead, it has, its special property is it has very low melting point. Get it? It has very low melting point. Because of that, as soon as 8 ampere of current flows through here, what happens? As soon as 8 ampere of current flows through here, what happens? This wire would get overheated. Understood? As soon as 8 ampere of current flows through this circuit or through this fuse wire would get overheated, whereas this red wire, it won't be overheated, only the fuse wire would be overheated. And because of that temperature, this wire melts down, since it has very low melting point. And what happens if it melts down? The circuit is broken. See, that's why the more than 7 ampere of current will never flow through the circuit. Whenever there is more than 7 ampere of current, the fuse melts, okay, and protect the circuit from that overloading. Understood? So if the fuse is working, then will there be any chance of house firing, any chance of that devastation? No, definitely no, because this wire can hold up to 15 ampere of current, and the fuse will never allow more than 7 ampere of current to flow through the wire. Okay, that is the role of fuse. Any confused? Well, however, if you do not choose your fuse properly, then what might happen? What might happen? See, since because of this 7 ampere fuse, you got a lot of trouble. You wanted to run a washing machine, okay, and washing machine draws more than 15 ampere of current. Then every time you turn on your washing machine, the fuse would go out. Okay, being troubled by that, what you did, without consulting anyone, you changed the fuse. You changed the fuse with higher rating. Let's say you changed it with 25 ampere of fuse. Okay, you changed 25 ampere of fuse. You installed 25 ampere of fuse in your circuit, and your washing machine draws up 18 ampere of current. And since the capacity of fuse is 25 ampere, will it be heated by 18 ampere current? No, it will not be heated by 18 ampere of current. No, it will not be heated. So that amount of current will definitely pass through the main wire. And remember, what is the capacity of wire? 15 ampere. So in this case, because of this 18 ampere of current, it happens to be overloading, and that overloading can cause severe accidents, devastation. Okay, that is why capacity of fuse or rating of fuse must always be less than capacity of wire. Understood the point? Understood? Okay, what I said that rating of a fuse wire must be lower than capacity of the circuit wire. Well, this is an important point. Okay, rating of a fuse wire must be lower than capacity of circuit wire. Now you understand what is fuse. Okay, basically fuse is a circuit breaker. Okay, you can add that in your description. Your fuse is a piece of thin wire. Okay, here you can write fuse is a circuit breaker. You can add this. Yes, fuse is a circuit wire. Okay, fuse is a piece of thin wire. Okay, fuse is a piece of thin wire which melts when certain amount of electricity flows through it. For example, in a fuse of rating 5 ampere, it melts as soon as 5 ampere of current flows through it. In market, available ratings are 3 ampere, 5 ampere, 10 ampere, 13 ampere, 15 ampere and 30 ampere. Well, any confusion over here, up here? Okay, what is the fuse made up of? That also we have discussed previously. Fuse, it is made up of an alloy of lead and tin that has low melting point. Okay, fuse is made up of an alloy of lead and tin that has low melting point. Okay, now what is the purpose of keeping a fuse? That also you already know, isn't it? We have discussed that in detail over here. Okay, what is the purpose of keeping a fuse? Let's see the note. Take it. A fuse is connected to protect the circuit from firing incidents, short circuit or overloading. Okay, firing incidents, short circuit or overloading. Okay, because of short circuit and overloading, firing incidents might occur. Okay, short circuit is a condition where plus wire and minus wire would connect directly. Okay, in that case, very high amount of current would flow through the circuit. Okay, that also causes overloading. Yes, okay, read here. A fuse is connected to protect the circuit from firing incidents, short circuit and overloading. I just told you what short circuit is. Suppose the wires used in a house have capacity of 17 ampere. When more than 17 ampere of current flows through the circuit, firing may occur. If fuse of 15 ampere is placed, the fuse wire would melt as soon as 15 ampere current flows and breaks the circuit. So the circuit wire would never receive more than 15 ampere current and prevents firing incidents. Okay, any confusion up here? And let me go to next topic, MCB. MCB stands for miniature circuit breaker. Well, it is also a type of fuse. It is advanced form of fuse. It is advanced form of fuse, but actually it is not a fuse. See, it is advanced form of fuse, but it is not a fuse. That means it is a developed or advanced device which works like a fuse. That means which works as a circuit breaker, but it is not a fuse. Okay, see, you have seen this kind of device as at your home in your household circuit. Well, this kind of device is miniature circuit breaker. Circuit breaker means the one that breaks the circuit, just like fuse. Fuse is also a circuit breaker. Okay, so this is also a circuit breaker, but it is a miniature or smaller version of actual circuit breaker. Actual circuit breaker that is used in powerhouses and local stations, city stations. Yes, they have larger circuit breakers, but this is smaller version of that circuit breaker which is adapted to be used at home. Okay, previously in past when the fuse was used back then, if fuse happens to melt down, then you have no other option but to change the fuse, isn't it? If fuse melts, then you have no option but to change the fuse. Okay, but in this case it breaks the circuit by moving this lever, this yellow lever. See, if it moves down, it breaks the circuit. If it moves up, it is moved upward, it connects the circuit, it completes the circuit. Okay, so whenever there is overloading or short circuit or any other incidents, yes, heating incidents, or if there are any abnormalities in the circuit, then the switch automatically comes down. When the switch comes down, circuit is broken. Okay, and your circuit is protected from overloading. Okay, and after you correct what was wrong, after you correct, then you can again switch, you can again pull the lift upward. Yes, and as soon as you pull this lever upward, the circuit will resume. The circuit will be completed and electricity will resume. Understood? Any confusion up here? Okay, so actually you don't need, according to your syllabus, you don't need the detail of this MCB, you don't need how does it work, and yet since many students ask me how does it work, I have searched for this diagram regarding its working mechanism. Okay, let's see here. Okay, here you can see this is a magnetic element. Yes, this is a magnetic element, and this is bimetal element. Bimetal element, it is made in such a way that when it becomes overheated, it changes its shape, or it expands. Okay, it expands and it moves away from its position. It is like a spring. Okay, so in normal condition you can see the circuit is completed. Load is here, line is here, yes, and like this, through this magnetic element the circuit is completed, isn't it? The circuit is completed. But in the event of overloading, what happens? This bimetal element, it gets heated. Okay, when excess amount of current passes through this bimetal element, it gets heated, and when it gets heated, it bends, it changes its shape, and as it changes its shape, it hits this bar. See, it is also called trip bar. It hits the bar. When it hits the bar, this part, it will move forward. Okay, it will move forward and it will pull this overall latch backward. Okay, here it acts like the lever, sorry, fulcrum of lever. This point acts as fulcrum of lever. So when this bimetal element hits the trip bar, the latch moves backward. Okay, the trip bar moves forward and the latch moves backward. And when it moves backward, here you can see the connection here is broken. Yes, and when the connection is broken, it is moved upward. Okay, it is moved upward due to the magnetic field of this electromagnet. Okay, and as soon as you reset the switch, what you do, you actually pull this backward. You pull the bimetal element backward. Okay, by doing so, the latch will move forward due to spring action. The latch will move forward and it will pull it back to the usual place. Okay, now this is the actual diagram of the MCB, the inside of MCB. You can see this switch. Okay, this is bimetal element, okay, and here this whole structure is actually the latch. Okay, this whole structure is latch and this is magnetic element. Okay, and you can see when the switch is moved upward, this is from your current gets inside the MCB. Yes, from here you can see through this knot and then through these wires the current passes through this circle and then through the latch, sorry, bimetal element, and from bimetal element it moves to this knot, and from here it will move out. Again, that way the circuit is completed. But when the switch moves downward, okay, sorry, but when in an event of overflow, in an event of overloading, what happens, this bimetal strip, it gets overheated. Okay, and because of its overheating, it changes conformation. Yes, it moves, and when it moves, this overall latch, the structure of overall latch will be changed. Okay, the overall structure of this latch will be changed and the switch is pulled downward. Okay, the switch is pulled downward, and because of that, you can see this part, previously this part touched here. See, you can see this part was touching here, but since the change of the structure of latch, this part, it has moved downward, and when it moved down, see, the connection between these two is broken. Okay, and that way the circuit is broken. Okay, and when you move the switch back upward, when you pull the lever upward, then what happens, this part is moved upward. Okay, because of, see, if you move this upward, this will be pulled down. Okay, this lever will be pulled down, and when this is pulled down, this will move up. Okay, as this moves up, it will move this whole part also upward. Got it? Okay, that is how MCB works. Okay, so MCB works by using the principle of thermal expansion. Okay, MCB works by using the principle of expansion due to heat, that is also known as thermal expansion. Okay, you need to know only that much. Let us see. Miniature circuit breaker, MCB, is a developed form of fuse that uses thermal expansion and tipping mechanism to break the circuit. You understand the tipping mechanism? Yes, as you see here, it tips over. Tips over means all down. Hey, all down, it tips over. Okay, MCB is more advanced than common fuse for following reason. If overload occurs and fuse breaks the circuit, the fuse must be replaced, but the MCB can simply be reset. It does not have to be replaced. So MCB is more advanced than common fuse. If overloading happens in your house and the switch lever comes down, then what you can do, you can simply pull it up. Okay, when you pull it up, the circuit resumes. As simple as that. Yes. Okay, common fuse only has single piece of wire enclosed in an insulated box. You can see the structure of common fuse. It is quite simple, isn't it? There is only a box which surrounds a thin piece of metal, but in case of this miniature circuit breaker, you can already see how complicated its structure is. Okay, sometimes it is even difficult for me to understand the overall structure. Okay, one moment I study it, I understand, and the next moment I forget it. I again get confused on this. This is that much complicated. Okay, because so many levers have been used here. Okay, an electromagnet is also used here, and thermally expanding metal is used here. There are so many components used here, and its mechanism is complicated. Okay, common fuse wire only has single piece of wire enclosed in insulated box. MCB contains delicate structure and mechanism enclosed in an insulated box. Now, because of these two reasons, MCB is considered more advanced than common fuse. Okay, any confusion? Okay, now the next thing, the last thing in this lesson we need to discuss is switch and fuse are always installed on live wire only. Why? Let us see this diagram once again. You can see here. Okay, this is live wire, this is neutral wire. Yes, this is switch, and you can see switch is placed in live wire. Okay, let us see another example. Here you can see the fuse wire. The fuse wire, they are also kept in red or live wire. Yes, they are not kept in blue wire or neutral wire. Okay, fuse wire is always kept in live wire, and switch is also kept in live wire. Why is that? Why is that? Okay, now let us suppose the switch first. If you keep the switch in live wire, then whenever you turn the switch off, the circuit is broken. Yes, and there is no residual current in the device. Yes, because the supply of electricity is completely cut off. There is no residual in the device, residual electricity in the device. So even if you happen to touch the device, it will not cause electric shock. It will not cause electric shock. However, let us take an example in which the switch is kept in neutral wire. Okay, let me pause. Okay, this is a circuit in which switch is kept in neutral wire. Okay, and you know that electricity flows through live wire. Yes, so even when switch is off, I have switched it off, isn't it? The bulb does not glow, the device does not work, but you can see it is still fed by live wire. It still contains electricity, and yet it is receiving electricity, and yet since the circuit is not complete, this device will not operate. But if you happen to touch it, then suppose this is you. Okay, suppose this is you and this is your hand. If you happen to touch it, then through your body to the ground, the circuit is completed. See, this is source of electricity. The electricity will pass through the device, then through your body it will pass to the ground. See, through your body that circuit is completed, and in that way you will get an electric shock, indeed a continuous electric shock. Okay, that is why the switch should not be kept in neutral wire. Okay, now if you keep the switch in live wire, let me work a little bit here. Okay, let me work a little bit, it will take a few moments. Okay, now I need to change its color to red. Okay, suppose that switch is kept in live wire. See, in this case, if the switch is kept in live wire, then by switching it off, the current supply to the device is completely cut off. Okay, even if you touch it, there is no current. If there is no current, then it does not matter whether the circuit is complete or not. And know that through neutral wire you do not receive any current. Okay, in this way electric shock is prevented by keeping the switch in live wire. Switch should never be placed in neutral wire. You understood the case of switch? Now similarly, let's discuss about the case of fuse. Okay, I need to change the symbol for fuse, and it be like this. Okay, suppose this is the symbol of fuse, yes, and I keep it here in live wire. Now suppose the wire, the capacity of wire is, suppose the capacity of wire is just 15 ampere. Okay, the capacity of wire is 15 ampere. Suppose, okay, just suppose the capacity of wire is 15 ampere, and somehow the device used here, it draws up a current of 20 ampere. It draws up current of 20 ampere. Then if the fuse is not kept here, then you know that 20 ampere of current will flow through the circuit, and because of that current the circuit wire would be heated up, isn't it? It would be heated up. Yes. Okay, well, I need to keep this fuse down here, not up there. And when the circuit wire gets heated up, what happens, you know? Okay, it might cause firing. Yes, that is too much detrimental. It might cause firing. Okay, so if you have kept a fuse here whose capacity is 12 ampere, if you have kept a fuse of 12 ampere, then remember the capacity of fuse must be capacity of circuit wire. Okay, if you have kept 12 ampere fuse, then when the device tries to draw 20 ampere of current, it will draw 20 ampere of current from source. From here 20 ampere of current will flow. From the source 20 ampere of current will flow, because your device is drawing that current. But as soon as this current reaches the fuse wire, what happens? Because of its capacity, it melts. Its capacity is only 12 ampere, but 20 ampere of current is flowing. It melts, and when it melts, okay, when it melts, let me break it here. Okay, add anchor, a segment delete. why it is not selecting the segment? Still it is not working. Okay, I need to add more anchors. And then okay, let me resume. So as soon as 20 ampere current flows through this fuse wire, it melts down, and when it melts down, the circuit is broken. So this 20 ampere of current will not get to flow through the wire. Okay, in that way your circuit is protected. Yes, but if you used the fuse wire, if you use the fuse wire in neutral wire, then what happens? Let's see that case as well. Okay, let me resume. Okay, if you use this fuse wire in neutral, then what happens? This device, it is drawing 20 ampere of current, isn't it? So 20 ampere of current is supplied by the source, and this 20 ampere of current will flow through your circuit wire. See, the capacity of wire is only 15 ampere, but 20 ampere of current is flowing through the circuit wire. Okay, and after it flows through the circuit wire, only then it reaches to fuse wire. Okay, when this current reaches to fuse wire, the fuse wire melts, but before it even reaches to fuse wire, it has already done the damage on circuit wire. Okay, shall I give you a funny incident? Okay, let us suppose this is an important person. Say this is a king. Okay, this is a king. Okay, and here is an imposter. Imposter means a person who wants to kill the king. Here is an imposter. Yes, and the imposter wants to kill the king, and to do that it is using a gun. Okay, the imposter is using a gun to threaten the king, and the bodyguard of king, there is a bodyguard of king as well. Suppose the bodyguard of king does not have any weapon, then what is his last option? What will be his last option? To be the shield of king, isn't it? Bodyguard of king. Okay, to be the shield of king. What does the bodyguard say in this case? If you want to kill the king, you have to first kill me, isn't it? The bodyguard would say that. If you want to kill the king, then you have to kill me first. Without killing me, you cannot get to the king. The bodyguard says that. Yes, and even if the imposter happen to shoot out, then the bullet will pierce the bodyguard, and the king will be protected, isn't it? Now this is live wire. Suppose this is live. Okay, this is the source of electricity. Okay, this is the source of electricity, and the path through which the bullet will come, it is live wire. Just suppose, okay, it is live wire. Yes, and the king is actually a device. Okay, and the bodyguard is a fuse. See, in this way, by staying in the live wire, or by staying in the path between device and the source of electricity, fuse protects the device. But what happens if the bodyguard stays behind the king? Okay, this is quite funny or interesting, whatever you want to say. If the bodyguard stays behind the king and boasts, like it says that, see, it says to imposter, if you want to get to the king, you have to get to me first. You have to kill me first. Before you kill me, I will not let you touch the king. Will he be able to protect? हेर त यो राजाको बडीगार्ड हैन, राजाको बडीगार्ड है, यो बडीगार्ड नर्मली ओके यसलाई म ब्ल्याक गर्छु है त ल बडीगार्ड नर्मली के हुन्छ, यो राजालाई मार्नलाई कोही आए, इम्पोस्टर आए र उसले चाहिँ गन राजातिर फर्काए भने बडीगार्ड राजाको अगाडि आएर बस्छ, लो मार्छस् भने पहिला मलाई मार, तैले राजालाई मार्नुभन्दा अगाडि मलाई मार्नुपर्छ, लो म आफ्नो छाती थाप्छु राजालाई बचाउनलाई, यसरी बस्छ। अनि इन केस यसले गोली चलाइहाल्यो भने पनि राजालाई लाग्दैन, बडीगार्डलाई लाग्छ, राजा त बच्यो नि हैन। तर के हुन्छ यदि चाहिँ बडीगार्ड राजाको पछाडि बसेर भन्छ, लो तँलाई राजालाई मार्नु छ भने पहिला मलाई मार्नुपर्छ, आइज भनेर भने गोली चला, चला गोली भन्यो भने के हुन्छ त, डेफिनेटली पहिला राजालाई लाग्छ। पछि यो डिभाइस भन्दा पछाडि भनेको कुन वायर हुन्छ त, डिभाइस भन्दा पछाडि कुन वायर हुन्छ, यु नो द्याट डिभाइस भन्दा पछाडि न्युट्रल वायर हुन्छ है, डिभाइस भन्दा पछाडि न्युट्रल वायर हुन्छ हो। यसरी हेर त अब यहाँबाट बुझ, यदि तिमीले फ्युजलाई चाहिँ न्युट्रल वायरमा राख्यौ भने इट विल बी युजलेस हैन, फ्युज न्युट्रल वायरमा राख्नु भनेको युजलेस हो। ओके दिस इज जस्ट एन एक्जाम्पल है। ल अब यसको एन्सर लेखौँ, म एन्सर लेख्छु, त्यतिन्जेलको लागि म भिडियो पज गर्छु है, एन्ड देन ओके हियर इज द नोट, नाउ यु क्यान पज द भिडियो and copy it. And well, this is the last topic in this lesson. With this, our lesson has been completed. Now you need to do the exercise of this lesson and submit to me, okay, within tomorrow. You should not take very long time for doing your exercise. And also with this lesson your physics part has been concluded, okay. In our next class, starting from our next class, we will begin biology classes. Yes, okay. Until then, I'd like to wrap up my class. Okay, thank you class. We'll see you in our next class.